refueling at CALSTAR and life support are going to send as many helicopters as possible, but they'll have to go soon.
Base 1 calling you today.
We're starting to get multiple phases.
Hang on, we have no coming in.
5-2 team entering.
Able to move upwind from those fields.
The rating for the community will have an impact on the premiums that people would pay in their insurance. This would vary from insurer to insurer, and we provide a benchmark classification system for the insurance industry, normally on a scale of 1 to 10, with 1 being the ideal or best protection and 10 being unprotected. We call it a survey to try and determine the capability of the fire department in providing alternate water supply in lieu of hydrant protection. Hydrants are, in most communities, the mainstay of the water supply system. However, in a lot of rural communities, the fire department has to bring in their own water supply. The water supply can either be determined or brought in by tankers, shuttling water back and forth from water supply points, or by the laying of large diameter hose from distances to needed fire flow locations. 3 major areas are included in our evaluation. The fire alarm section of how the public will call into the fire department and how the fire department is alerted so that its members can respond to the fire. The second area would be the fire department itself, what their ability is in terms of rolling stock, the number of engines, ladder companies, and so forth, as well as their training programs, their staffing levels, and how those fire apparatus are equipped and where they're located in the community. And then the third major area is the water supply system. Is there adequate water for needed fire flows to control a fire in different buildings throughout the community? One of the things we look at first is what hazards are in the community and what water flow is needed for those. This is what we call our needed fire flows, where we analyze individual buildings and develop a needed fire flow for the complete building. The needed fire flow is used then throughout the communities at different locations, and we see what the fire department can provide in meeting that needed fire flow and coming up also with a minimum fire flow that they can sustain over a certain duration of time. The first benchmark would be our minimum to apply the credit or to provide a better classification for the community. The minimum is 250 gallons per minute for a duration of 2 hours. And above that, then we start looking at single-family residential properties, and they may be 500 gallons per minute based upon the spacing between buildings and exposures. Commercial buildings can range everything from 500 up to 3,500 gallons per minute based upon the size, construction, occupancy, and exposures to those buildings. In looking at evaluating the department, our major emphasis in this situation is determining how much water the fire department can get to the scene of a needed fire flow. And it may be done either by tanker operations or by large diameter hose, relays, or a combination thereof. And we try and determine where the water supply points are located, how far the fire department has to travel, and the time it takes to set up this whole operation. We look at the fire department's plan of operation. If the fire department has one station, obviously we'll be evaluating their operation for all their apparatus. We also look at automatic aid of neighboring communities and neighboring districts providing support to that community. And we evaluate the tankers based upon how far they're coming from and other supply point pumpers as far as where they're coming from and where they're setting up. So everything can be credited based upon the time of getting it into service in a reasonable fashion. The next step is probably to identify some water supply points and to have these points certified so that we can rely on these in drought times. One of the things that we look at for example, ponds, is to look at a 50-year drought period to certify that pond and come up with a amount of water that is available for fire department use. When any type of water supply point is privately owned, we request to see some documentation that there's an agreement from the property owner that allows the fire department to use that water throughout their district for fire emergency purposes. Access to the water, obviously there needs to be a pumper, and generally speaking, to draft from that site, and there needs to be access that that pumper could get to that location. Obviously the dry hydrant brought out to a roadway is probably the best type of access point in getting the water from the pond. It makes life a little bit easier and simpler. In our water supply evaluation, the best crediting is for a dry hydrant because it's a permanent setup, a water supply point there will be easier, most likely, to hook up and take less time to set up that water supply point. In some of the areas that are and I would call the easy things to do, some of it requires major expenditures. For example, if a ladder truck is needed in a community that does not have a ladder truck, that can be a major expenditure. The areas that don't require the major expenditures are normally training. The more training a fire department does in different areas can improve their classifications or their work toward improving their classifications. And many times it's just a matter of time and effort. Today in many volunteer companies, though, time is at a premium as well, and it's very difficult with everything else being done in the character of today's society of having the time to do all of that.
Bill, your community's been through this. What's it like?
It was quite a challenge, and there's a lot. We took it in a step-by-step approach. We identified our needed fire flows. We have a small downtown district, if you will, no hydrants or anything like that. But we needed to protect those buildings. There's some stores and churches and whatnot in there, and our fire flows were upwards of between 2,000 and 3,000 gallons per minute. And the water was a little ways away. So then we went through and identified what water sources we do have closest to our downtown area, if you will. And those came up to being a creek that pretty much runs through the back of the little town, and also some miscellaneous ponds in the near area. And at that point, we identified how we were going to get the water to the fire scene. And we pretty much focused on the middle, the way our town is laid out and stuff, and the distance from the water. And we ended up doing a twofold system as far as laying a 4-inch line in, which consisted of about 3,500 foot, and also a tanker shuttle from, we happen to have a fire pond, a water pond at the fire station. And we demonstrated our proficiency at doing so. And it brought a lot of our neighboring, we rely heavily on the mutual aid system for extra equipment, water primarily, and also manpower. And it brought all the fire departments together, it worked together. At this point in time, they're very efficient at doing this now. It's not trying to explain to them during the middle of a fire how to go about it, but you just tell them what you want and it's going to get done.
Harry, Wyoming County went through a rather long process, I understand, to do this, but it was a step-by-step process. Share with us just some of the experiences that they had to kind of go through to get ready to have this water flow.
One of the important points here is that the Insurance Services Office goes through at a periodic time, maybe 10 years, maybe 15 years, depending upon the population and a number of factors. And they go through for the reclassification. And the community of Strikersville was coming up for a reclassification. And I happened to be in the Bureau of Fire office and working with the field representative. And Bill was wearing his other hat at that time. He was the fire chief for Strikersville. And we were really concerned the fact that they had not moved forward. In fact, they might be regressing in terms of their ISO classification. And that's what started all of this planning process, thinking through what can we do to this community and its surrounding area to improve their ISO public protection classification. And that's when we got into understanding the planning elements. We needed to identify the risks, which are the needed fire flows. Bill was referring earlier to this specific building, which happened to be the Catholic Church, which required 2,500 gallons a minute. Now, how do we get water to that? And Strikersville came up with something very innovative. They had a farm pond, as I call it, near the fire station where they could draft from. Well, instead of doing that, we brought a water line in from that to the fire station and installed an industrial fire pump with a header on it so they could fill the tankers right at the fire station without going and drafting, which is a time-consuming operation, especially in the wintertime. So it was little innovations along the line, and each one is peculiar and unique to itself that you have to go through this planning process. And on the basis of that, we worked out a mutual aid operation, automatic aid operation for response to the community of Strikersville and to its graded area around it. And they were able to go from a semi-protected Class 9 to a protected Class 7, which is significant. It's a significant improvement.
But what I'm hearing you say here is that you looked at what was in the community and what was
Yes.
available in the jurisdictions,
Yes.
and you based your planning on that.
Yes, and then we did some innovative things, and this is when they got into large diameter hose to move the water from the stream up to the church, along with the tanker shuttle. So we used the combined mobile tanker shuttle operation along with a relay operation to get the quantity of water we needed at the church.
Yeah, we've tried to incorporate a lot of different companies. The drill that we had this past fall, where we did a large diameter hose relay to see just what it took to do over a mile of large diameter hose. We incorporated the draft capabilities from a pond. We used a pond, and in an effort to do our part for the ecology, we dumped it back in a creek so that we didn't just throw it out in the fields. We also incorporated a ladder truck so that everybody could have a little time working. So we try to incorporate several things into the drill. And we learned so much because, first off, not a single person there had ever done a large diameter hose relay to see how much we could get out of a 5,600 foot relay is what it turned out to be, a 5-inch hose. We didn't know how long it was going to take to set up. We didn't know how many pumpers we were going to need at the draft source. We didn't know how we were going to be able to deliver it 48 feet up a tower ladder. So we brought all these questions together and invited the entire county as well as neighboring areas in central Maryland, and had participation from several different counties and companies, and incorporated several different people's procedures and apparatus and things of that nature together so that we could produce results and answers for each of these questions. As it turned out, we learned some things as we go. We found we had a bad dry hydrant for one thing. So we learned something practical from the drill. We also learned that there was a side thing that nobody had ever even thought of, in as much as the apparatus was creating so much heat out of the exhaust pipes that it was melting the street. So we had to deal with that. So we learned a lot of things through this drill that if and when the day comes that we have to, get out and do this for a large incident somewhere, we've got folks around us saying, gee whiz, now I understand why we did these things. This was worth doing because now I know something that somebody else doesn't know. I'd like to also just echo a point that Jim made. The little bit of competition factor and the fact that, hey, if they can do it, we can do it, is a big, big motivator in the fire service. I think we all here would agree with that. And getting to that, when you can get the companies involved to that degree where they want to go out and be as good as Wyoming or be as good as whoever, that makes the whole drill worthwhile because these folks are then getting into it, they're trying things, they're learning things, and it sticks with them because it becomes a conversation piece around the station.
Harry?
I had the privilege of observing the drill that Doug is talking about, and they laid a mile of 5-inch hose, and within 15 minutes they were delivering over 2,100 gallons a minute from an aerial ladder pipe, as indicated by the digital readout flow meter on the back end of the ladder pipe. Very impressive.
I think that's a point that I think with all of you have been involved, this is an impressive demonstration, isn't it? Absolutely. Not just to the community, but to the firefighters as well. Yeah. Fred?
Doug makes a good point about training, about the value it shows to that. ISO realizes that in our evaluation of alternate water supply for tanker operations, we will develop a factor based upon how much training is done on an annual basis with the automatic aid fire companies. And simply for the most credit, 4 times a year of some type of get-together of doing something with the companies to make sure that everybody is on board with everything so that at the fire site we're not figuring out what to do. So that's a very important area, and the same with communications, the ability to communicate on radios, portables and mobiles, so that when they're calling in tankers into a proper sequence of knowing which is the most efficient tanker to dump first and holding off another one, that there's the communications capabilities there to do that. And that's something we evaluate as well. It's important.
Yeah, communications, I work in communications. I think these are so large that is almost its own channel. You just have to give a channel to water supply. I mean, it's such a large operation, to keep these tankers rolling and keep them in sequence and definitely give them their own channel.
We develop a needed fire flow in the fire suppression rating schedule, the document that we use to evaluate communities. We have a procedure that looks at the construction, effective area, the occupancy exposures, and communications to a particular building. We look at that building and then calculate out a needed fire flow from a formula. And we provide this information to the fire departments for buildings that we have surveyed in the community as well of a needed fire flow report. Which is one service from ISO that is available either online or through our customer service units. And that's the establishment of the requirements for the water supply. Now, as long as you meet 250 gallons per minute for a 2-hour duration, normally that can help that community's classification. There are other factors that go into scoring a Class 8 from going from a Class 9 to an 8. The threshold is the 250 gallons per minute for 2 hours, along with achieving enough points in the fire alarm and fire department section of the fire suppression rating schedule. The needed fire flows establish the goal for that particular building, but the more that can be credited for that will help improve the classification. Okay. Thus, if 800 gallons per minute
You can get a better classification based on that. Now, when we go into the community and we start looking at this, do you normally just, and all of you have these, do you go to the place that's going to need the most water and base it on that, or do you look at several large fire flow needs? How do you figure out what you're going to do?
Throughout the community, we take a representative sampling of different structures around the community, pretty much along the exterior points, to look at the longest responding distances from either the fire station or from the fill site, and also look at different ranges of requirements so that we don't look at everything that's 3,000 gallons per minute. It's not fair to the community. So we have a representative sampling throughout the community, geographically, types of properties, dwellings, commercial properties, and so forth. So there is a sampling done, and we normally have enough that gives us a good average.
Okay, so we're looking at the average. Harry?
I want to clarify something. A fire district only has to make a demonstration at one representative site. ISO has a computer program, which is nothing more than the time and motion study program, which can evaluate these other sites without actually doing a demonstration based upon the known resources.
So once you've surveyed the resources, you can use the software to figure out what you need for the other sites, and we don't have to run all over the roads.
You just have to do one demonstration.
Just have to do one demonstration.
Yes.
I think one thing you have to look at is the resources within your county. I mean, do you have tanker companies that can offload quickly, that can fill quickly? I mean, these are standards that are developed within a county. I know Lancaster County, we have a standards committee. We develop tanker standards, okay? You have to offload from the side and dump from the back or the sides. I mean, there's different things you can do. Because you don't want to bring a tanker in that's going to take time. I mean, you're going to lose time, you might lose water flow. So that's one aspect of it that I can say that is a start. I mean, in addition to that, of course, delivering those resources then to the scene in bulk is what you need to do. A lot of what we're talking about is rural America, and we have long response times to some of these locations, and if you're only going to deliver a little bit of water to that call once you get there, you're going to be behind the 8 ball the whole time, because now you're going to call for resources that take twice as long to get there maybe. So I think the whole thing at the start is again, it sort of all goes back to pre-planning.
You have to be prepared for the worst, okay? It's a lot easier to downgrade than it is to upgrade. At the point in time of needing to upgrade, it's probably predominantly too late already, okay? Because it takes time to get your other resources in. So the automatic aid process works very efficiently, on that part of it. Communication is also key, to get everybody at the table, and so everybody's familiar with how it's going to work and what your resources are and how we need to pull that program together and then implement it.
Jim, that sounds to me like coordination.
It's very much the key. When Strikersville ran their demonstration project, one of the things that Bill did as chief was bring all the companies together. And it was kind of an interesting movement, because once you ask what's the first step, once other county companies saw that the success was there, it was kind of contagious, and it kind of led them to believe that, well, if they can do it in Strikersville, we can do that. Plus there's a competitive factor there too, that everyone wants to do the best and be the best. So it has been pretty contagious as far as trying to move water and move it efficiently. The bringing of water consistently is really the key, though. If you run out of water, no matter what you've done in the first 10 minutes or 15 minutes is really a useless cause. So having that automatic aid and having people coming, it's easier to turn people around than it is to ask them to start coming.
comes down to two things as I see it: location, 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 and training, training, training. If you do that, if you have the locations and you know how to apply them, and you train in doing so, you're going to make the grade.
What kind of locations are we talking about?
In the rural setting, you're talking basically farm ponds, creeks, or maybe even a lake of some sort. You take it from that point, you take it how you get it from a body of water or a stream of water, how are you going to get it out of there, and how are you going to get it to the scene of the incident. Generally, there's two practical ways of doing so, one by tanker relay and one by 4-inch hose relay.
There's a couple things we have to look at. We have to look at some type of professional that will know how to evaluate a pond, for example. And sometimes it's very basic of just doing some measurements and getting some calculations of it, and then looking at a professional to determine how much water is normally available in that pond, and then determine what the drop down is during a drought period, how much water is left, how much water that we can normally credit based upon a 50-year drought cycle. That's what we're looking at to see whether it's a credible pond for the ISO rating. There are a lot of water sources that the fire department may be able to use at certain times of the year that may be credited. For example, streams. Many times there's good flow in streams, but from July through October, they're dry. And we cannot credit those from our ISO standpoint. However, as long as the fire department's aware of that, they can use those in those times. But again, there has to be a plan. So if the fire is in July, there needs to be a plan where to go for water. One of the other areas we've briefly talked about is cisterns. A lot of communities today are installing 30,000 gallon cisterns, and sometimes larger, sometimes smaller. These can be an ideal source of water supply because they're not regulated by the weather conditions. As long as they're properly maintained and normally set up with a dry hydrant, very easy to get at.
So you can put your own in.
Yes.
You don't have to depend just on what's out there? Harry?
Modern adaptation of that now is we have fiberglass tanks that were originally developed for private water supply for sprinkler systems, but they are being designed now with a sump on the bottom so that it can feed into a dry hydrant, and they're commercially available and cost competitive with building a cistern. And all you got to do is take a backhoe and put them down below the frost line, and it's a neat way to have a self-contained water supply, as Fred said, that's not influenced by weather conditions.
That just has recently occurred in the area where I live in an effort to keep up with new growth. We're in one of the fastest growing areas in the country right now. Our county has adopted a procedure, a set of standards, and a law to back it up, where any new development over 4 houses has to have 30,000 gallon water tank in the ground with a draft hydrant, refill port, and vent before the development can be built. The option that we put to that, obviously, is that gives us the water that's required by ISO for any place in the development. And then the kicker to that is, okay, so what happens to the community with only 3 houses? The option there is the residential sprinklers. So we've given them 2 ways to go. They can put the tank in or they can sprinkler.
We need a lot of resources to do all this?
Not really. In many cases, we already have the necessary tools. We're just not applying them in maybe the most effective manner. For that reason, the Insurance Services Office in the United States Fire Administration, in an effort to help communities of all sizes, realized that all we really have to do in some cases is just kind of take a snapshot and share successful programs and initiatives happening in one part of America with another part. These opportunities are not secrets, but they may not be fully appreciated. So there are a number of opportunities that we're really working hard to share. The Fire Administration already has a series of materials available, a CD on testing and evaluating water supplies, the products that support this piece that we're preparing now. really are terrific tools. And they're not magic, they're not scary. They're just taking good practical solutions, common sense if you will, and making sure that people understand where they fit, where they make a difference with regard to the ISO ratings, and why those ratings lead to a safer community. So this has such a universal set of appeals that it's just a matter of identifying the need, applying the tools, and then evaluating that process, and then keeping up our skill sets. You can't do it once and then walk away. You've got to do it again and again.
Just to tie something in what Wayne said about it can be very simple, and the resources may be there all over the place. It may be that there's a number of ponds that are available, but has the fire department laid out and identified those and knows which pond to use in the event of a fire? Is there access to ponds, or is it a pond that cannot be accessible by fire apparatus to draft out of? So just identifying and coming up with a plan like that, and then looking at, for example, the automatic aid fire companies, are they assigned on a proper dispatch sequence to respond initially on a first alarm response, or as such as a tanker task force, of putting those resources together and using them in a plan? It's all there, it just has to be acted on.
There is a solution. It's how hard do you want to work? And I've looked at all the communities that we've talked about here and said, I can apply this to our community. And you do that through the work, through planning and seeing what works, whether in our case it was built-in fire protection that helped keep our insurance ratings and pump capacities on particular buildings that way, or whether it was a tanker shuttle operation or what. But the economic impact I use is that the ISO rating, if we can get it lower for the community and lower for a particular commercial risk, that saves everybody in the community money. And I always use the approach from a fire chief that we're the only service that puts money directly back into the pockets of the citizen. Because if we can lower your ISO rating, there's nothing else in government that I can do that puts money directly back in your pocket. And so that benefit is tremendous, and it ought to be an incentive for us to work to find the solutions.
We talk about alternate water sources. When you're unable to get to one of those that may not be ideally located, there usually are some other sources close by where we can tanker to or relay to. I think that the beauty of living in a rural community is that most landowners or farmers are very cooperative. So if there are farms or water supplies available, they're going to allow you permission to go on and use those water supplies.
Well, it's an interesting thing because you have departments that once were rural now have municipal water systems, and you have districts that run out of the municipal system right out into a rural area very quickly. Again, I think pre-planning is the biggest thing I can see here, and it goes along with location. You must go out and look at your hazard areas. You must go out and look at your targets and see where is the appropriate water source. Where can we identify, something where we can draft from that would be in a reasonable distance to get a tanker shuttle turned around in due time to get enough water supply. So basically, in Lancaster County, I mean, that's certainly what we've been trying to do, identify and pre-plan. And then it goes along with training. I mean, they're not the greatest drills in the world because they're very boring to some degree, but you must do it. I mean, if you don't do it, you're going to have mayhem on the radio and people asking for, what to do. If you do what Wyoming County does, and when you have drills, it gets to be routine. And I think that's the biggest thing.
You did it in Wyoming County. You went from a 9, I think you said, to a 7.
Correct.
So what does that mean?
Right, the immediate, meaning of that is that it's a savings to the homeowner, the local homeowner and business owners. Going from a classification of 9 to a 7 netted our homeowners between 25 and 35% in savings on their fire insurance premiums. We did get some positive feedback from that, from our citizens in letters to our department and to the Bureau of Fire and whatnot. And people, we're giving something back to the people, the community. And as was mentioned earlier, and you know, of today's economic being and stuff, that's very important to people to get is not have to put a whole lot of money out and to see a savings and to see a group of people come together and perform efficiently and professionally is very important to them.
Impact on the fire department?
I can't elaborate enough on what the impact was, even not even just to the, say, the Struggersville Fire Department, but to all the fire departments around their neighboring departments that participated in it through the mutual aid agreements and automatic aid agreements. And it went even farther than that and expanded across the county because other departments picked up on the way we were, say, doing business and performing out there at the time of a structure fire. And it made them more proficient too. You drill, you practice, you perform, you get efficient at it. And as was mentioned earlier, when there's that alarm of fire, a major structure fire in any area of the district, the people, the departments respond, they get there, they know what is expected out of them. They don't have to be told or explain how to go about it. It just comes together, it gets done. Every scenario is a little bit different, but it gets done. And I believe we've seen a lot of a decrease in total losses of structures within the district and stuff. They're being rebuilt, and which end result is it's saving insurance companies paying out their the monies and their claims, and in turn that gets turned over to the homeowner. Their premiums are a little bit lower.
I'd like you to give us what you consider one or two of the key points that a department ought to look at if they're going to be serious about doing this. And it could be a benefit, and it could be even a caution of what you need to be available. And Harry, I'd like to start with you on this one, because I know you've done this in a lot of different communities.
Water supply is key to this. And I have found that the best resource to start with is your local office of soil and water conservation. These typically have professionals. They can assist you. They also can put you in touch with, like, the Department of Environmental Conservation. And we can get really sophisticated on this. Department of Environmental Conservation puts what we call weirs in streams to gauge the flow for fishery. And in Bill's case, I know on Owatka Creek, all we got to call is DEC, and we know real time how much water's going past that bridge.
Fred?
Having a good plan, as everybody's mentioned, is essential, and you really need to almost put it in writing. And this is one of the things that fire departments just terribly hate to do, because it does take a lot of time and effort, you know, put it down in writing. But again, in the fire service, we tend to turn over, especially in the volunteer ranks, is that the chief 1 year, 4 years down the road may be somebody completely different. And if there's a establishment of a plan, we went through all this work and put together something, having a good operational plan, and it doesn't have to be volumes of material, just simple but written down someplace so that we can follow and update on there. Look across the websites on a number of fire departments across the country. I've seen some excellent plans out there that they put on their websites. So there's a resource out there that is just tremendous. The capability of the internet today, there's a lot of information that you can steal and call it your own on there, but don't reinvent what somebody else has done. Ask for advice from neighboring fire departments, get other people involved. Ask ISO for their assistance as well. We're more than happy to help out.
to what we've talked about earlier, location and training, of course, is important. Thinking outside the box with some of the examples that we went through earlier. But I think the need for a water supply officer on most of your incidents, and perhaps even within the company officer structure, can be very beneficial. This person gets out and trains with the water supply, knows the locations and the needs that we have out there, perhaps even works with the training officer in conducting these types of drills and so forth. Well, I mean, could be just infinitely beneficial to your water supply needs. The location and the training can all fall under this particular officer so that he can help with the coordination, the setting up, and things of this nature to make the whole thing work out.
The relationship between the fire departments and the community, I think, grew tremendously, you know, in both the projects in Wyoming County. The general public's out there, they're seeing that the fire department is doing something, okay, in a positive manner. And in the long term, the big bad picture, it's a savings to the community. And the people who were out there, we had a very good reception with the people in the fire department out there doing it. The public was watching it. There's a lot of questions that came around with it. It was, you know, worked through with the local media also. And so it wasn't just held right in that little community. It was, you know, county and multiple county-wide. And that's one of the bigger benefits.
Central point I'd like to make is out in the rural environment with these small volunteer fire departments. A fire department of and by itself normally cannot run one of these operations. It requires automatic aid. It's FRED defined, where companies are coming in automatically on the first alarm of fire from another fire district. So now we have the districts coming together, working together, becoming a more effective team. And in New York State, that's where the term fire coordinator's office comes from, to coordinate this activity, to make it happen, and make it a more effective firefighting machine, if you will.
And the economic benefit?
The economic benefit is really twofold. The reduction in premiums, but the increase in public support. Fundraising, volunteers depend on tax money, but they also depend to a heavy degree on raising money through bingo games, whatever, and the support from the community coming in with more dollars because they know what their fire department is able to do for them.
Why is water the agent of choice for fire suppression?
It's the most plentiful agent that we have.
Box 7-9, Company 7, Washington County, Company 8, Company 12, Company 8, Ambulance 78, Tanker 7, Washington County, Tanker 8, Tanker 5, Truck 5, Company 7 Thermal Imager due. 6900 block, Mountain Church Road, off Marker Road. Reported heavy fire with multiple exposures.
Uncontrolled fire is one of our worst enemies. It destroys our homes, our jobs, and our natural resources. According to the U.S. Fire Administration, every year there are 1.7 million fires in the United States. More than $11 billion in property damage and loss. 4,000 people die every year in fires and 22,000 people are injured. Data from the Insurance Services Office indicate that the problem is particularly acute in rural areas where the numbers of fire and the dollar losses are increasing due in part to inadequate water supplies. Up here on left. Yeah, that's right. As bad as these numbers are, they could be much worse if we didn't have the capability of confronting fire with its own worst enemy, water.
In communities with municipal water supplies, huge investments are made in storage facilities, pumps, pipes, and hydrants. Complex planning efforts determine the amount of water needed for domestic and industrial use. Now, consider the increased demands that will be made during fire operations. Not only does this water infrastructure need to be built, it has to be maintained, expanded, and tested so that when firefighters arrive, there will be enough wet stuff to put on the red stuff. The end result of the water system planning is a sufficient amount of water for the fire service. Enough available water to initiate and sustain fire suppression capabilities that correlate with local hazards.
Out in the rural areas, the situation is very, very different. Firefighters have to get the water where they can find it or bring it with them. Often the location of the water that is available is nowhere near the fire scene and frequently may not be readily accessible or even adequate to finish the job of putting out the flames. In other words, we need enough water for the initial attack and for a sufficient reserve quantity to sustain the attack. Of course, now we have to deal with the logistics of managing water supply as well as rescuing people and livestock and containing the fire itself.
Before we can start moving water to the fire scene, we first have to find it. The process of identifying water needs for firefighting begins with the community's overall fire defense system master planning process. This includes an assessment of local fire risks and the kind and amount of resources needed for fire suppression. Water supply needs should always be a part of the process and should address how much water is needed, where water is located, how we access the site, what is needed to move water from the source to the fire. For example, a school incident could demand more than 2,000 gallons of water per minute for a sustained attack, one that would not only bring the fire under control, but would extinguish it completely. Water sources for that incident might include rivers, lakes, ponds, cisterns, portable ponds, and even swimming pools. We need to prepare street maps showing the location of these supply resources. We also need to identify in advance the locations that require special access. Anticipating moving water to the fire scene is another stage of planning and includes determining apparatus and equipment needs. Moving water quickly in relatively large amounts requires the services of pumpers, tankers, and possibly even mini pumpers. Although mini pumpers carry relatively small quantities of water, each can move quickly and drive into more confined areas to begin a rapid fire attack. Decisions about these requirements come from an analysis of fire risk and available water supplies. But moving water is only one part of the problem. Other equipment is needed for temporary storage and handling at the scene. The planners have to consider using portable ponds for on-scene reservoirs, dump valves to quickly unload from tankers, hard intakes for drafting from rivers and lakes, and large diameter hose to increase the volume of water flowing to the pumpers feeding those attack lines. Additionally, planners need to look at the accessibility of the water in the community, the condition of driveways and farm roads, bridges over streams and gullies, the height above the shoreline water level, and the need for dry hydrants for rapid access to pond water.
Because the water management process from planning through implementation and on to drills and exercises is so complex, many fire departments appoint someone to serve as a water supply officer. That officer's tasks will include such things as calculating the water demand for individual structures, conducting training sessions on alternative water delivery, maintaining the location and capacity of water fill sites and highway maps, and establishing a dry fire hydrant program for selected groundwater sources. In addition, the person can serve as a water supply coordinator for fire incidents that require hauling or relay operations. There are many other tasks a water supply officer can perform, but they are determined by the community's needs and available resources. A key component of the water supply officer's job is working with the department's training officers to practice alternative water supplies.
This could include drills with apparatus operators, field exercises with mutual aid companies, and tabletop practices with officers making strategic and tactical on-scene decisions. To effectively apply alternative water supplies, departments need to work with these components and evaluate them. Planning for water supplies in rural areas is as important as applying water at the fire itself. In some cases, adequate resources cannot be located or planned, so optional adoption of automatic sprinklers for property are needed. Also, application mitigation measures, such as minimal building codes, can reduce the water demand for firefighting. But in areas where water can be found, the effective coordination of planning and operations can result in community-wide benefits and an increase in fire department efficiency and performance. The benefits may include reduced annual fire losses, improved effectiveness of fire department operations, and reduced insurance costs. In fact, the Insurance Services Office has a program of reduced insurance premiums for communities that meet particular guidelines of water supply and fire department operations. Adequate and available rural water supplies should never be happy accidents. They should be an integral component of community fire and emergency management master planning.